optical fiber cables work and how they have revolutionized the world around us. Optical fiber cable is made up of thousands of fiber strands, and a single fiber strand is as thin as a human hair. Optical fibers carry information in the form of light. Let's first learn some fundamental behaviors of light to understand the workings of optical fibers. The speed of light changes when it passes through a medium, and this change in speed is expressed by the refractive index. This variation in the speed of the light leads to another interesting phenomenon: refraction. To understand what it is, let us carry out an interesting experiment. In this experiment, light passes through a prism. You can see that at the interface, the light gets bent instead of going straight. This phenomenon is known as refraction. Refraction occurs when light passes from a medium with one refractive index to one with another refractive index. The light bends towards the interface when it goes from a medium of high to one of low refractive indices. Refraction is the reason why a pencil looks bent in a glass of water. This simple refraction technique is effectively used in optical fibers. Now, let's make this experiment a hypothetical one. Using some dopants, we are able to increase the refractive index of the glass in real time. As we increase the refractive index, the light will bend more and more towards the surface. After a time, you can see that the light will pass through the surface of the glass. If we increase the refractive index further, the light will suddenly come back to the first medium as a pure reflection. This is called total internal reflection. The total internal reflection is possible if we increase the incident angle rather than increasing the refractive index. In this case, at a certain angle called the critical angle, the light will come back to the first medium. This phenomenon of total internal reflection is used in optical fiber cables to transmit the light. The simplest form of optical fiber cable is shown here: cylindrical glass with a high refractive index. If the laser strikes the interface at an angle greater than the critical angle, total internal reflection will happen, and the light will reach the other end. This means that light can be confined in the optical fiber over a long distance, no matter what complex shape the fiber forms. Remember, total internal reflection happens between the high refractive index glass and the low refractive index air. However, optical fibers need a protective coating. A protective coating is not possible with this configuration. The introduction of protective material will replace the position of the air and cease the total internal reflection phenomenon. An easy way to overcome this issue is to introduce a low refractive index glass above the core glass, known as cladding. This way, total internal reflection will happen and we will be able to use a protective layer. Both the core and the cladding use silica as their base material. The difference in the refractive index can be achieved by adding different types of dopants. The optical fiber we have just constructed won't be able to carry signals for more than 100 kilometers. This is due to various losses that happen in the cable. This loss of signal strength is generally called attenuation. Absorption and scattering are the main reasons for signal attenuation. This is why you see amplifiers in cables after a certain distance. They boost the signal strength and allow signals to be transmitted over a long distance. The power required for the amplifier is drawn from nearby sources. Now, back to the main topic. How does the optical fiber transmit information such as phone calls or internet signals? Any information can be represented in the form of zeros and ones. Assume you want to send a hello text message through your mobile. First, this word will be converted into an equivalent binary code as a sequence of zeros and ones. After the conversion, your mobile phone will transmit these zeros and ones in the form of electromagnetic waves. One is transmitted as a high frequency and 0 as low frequency wave. Your local cell tower picks up these electromagnetic waves. At the tower, if the electromagnetic wave is of high frequency, a light pulse is generated. Otherwise, no pulse is generated. Now, these light pulses can easily be transmitted through optical fiber cables. The light pulses which carry the information have to travel through a complicated network of cables to reach their destination. For this purpose, the entire globe is covered with optical fiber cables. These cables are laid under the ground and below the ocean. It is mainly the mobile service providers that maintain these underground cables. AT&T, Orange, and Verizon are some of the few global players who own and maintain the submarine cable network. A detailed cross-section view of an undersea cable is shown here. You can see that only a small portion of the cable is used for holding the optical fiber. The remaining area of the cable is a mechanical structure for protection and strength. Now, the question is, where does the amplifier get power from under these deep oceans? Well, for this, a thin copper shell is used inside the cable, which carries electric power along the cable so that the amplifiers can be powered. This whole discussion simply means that if optical fiber cables do not reach a part of the globe, that part will be isolated from the internet or mobile communications. If we compare optical fiber cable to traditional copper cable, the optical fiber cable is superior in almost every way. Fiber optic cables provide larger bandwidth and transmit data at much higher speeds than copper cables. This is because the speed of light is always greater than the speed of electrons. The flow of electrons in a copper cable generates a magnetic field, even outside of the cable, that can cause electromagnetic interference. On the other hand, the light, which travels through the optical cable, is always confined within the fiber. Thus, the chance of interaction with an external signal does not exist. One more interesting feature about optical fiber cables is that any light signal which enters from the side has a minimal chance of traveling along the cable. Thus, the optical fiber cables provide high data security.